Scientists say they have found evidence for gravitational waves for the first time ever. The discovery was made by a group of researchers called LIGO, and if it's true, it marks one of the biggest scientific finds in decades. Gravitational waves are considered ripples in space-time. What is space-time? Let's try to visualize it by imagining it as this blanket. Yes, we're compressing 4 dimensions into 3. A smaller object on the blanket's surface doesn't change the shape all that much. It will just roll straight across. But if you place a bigger object with more mass on the blanket's surface, it warps the overall shape much more significantly and affects other passing objects. This is basically how gravity works in our universe. Objects seem attracted to each other, but really they follow the curvatures of space-time created by the presence of other larger objects. Now let's switch things up a bit. Instead of a blanket, imagine space-time as a pool of water. If you move an object through the pool, it causes a ripple effect outward. A similar scenario happens when large masses move throughout the universe. They produce gravitational waves that warp space-time. Everyone basically agrees that gravitational waves exist, but nobody has been able to prove them. In fact, the movement of every object in the universe supposedly produces these waves, but they're usually way too weak to be observed. So to find them, the scientists at LIGO looked for the biggest ones out there. That means observing 2 super dense black holes merging far away. This huge explosive event generates enormous waves that can be picked up by LIGO's observatories. Each facility is shaped like a giant L. The arms are vacuum-sealed tubes 2.5 miles long. At the end of each arm is a mirror. When the gravitational waves pass the mirrors, they warp space-time, making it appear that one mirror is closer than the other. The scientists can measure this phenomenon by timing how long it takes for lasers to bounce back from each mirror. The relative movement of these mirrors is incredibly slight. By the time the waves from the black holes make it to Earth, they only change LIGO's instruments by about 1/10,000th the size of a proton. That means these measurements are incredibly difficult to detect and are very susceptible to error. Plus, the science community has been burned before on gravitational waves. In 2014, scientists studying the early universe said they had found evidence for the waves, but later it turned out the measurements were just the result of cosmic dust. But finding gravitational waves is still a huge deal. It confirms the last big part of Einstein's theory of relativity that has yet to be proven. It could also open up a whole new way of studying our universe. Before now, we haven't been able to see objects like black holes or neutron stars because they are way too faint. But we could use gravitational waves to study these objects more directly than ever before.